UTM system. So you see the name comprised of two parts, the GCS and the PCS. And if you scroll down, you will see GCS North America 1983. Okay? So if you are using the geographic coordinate system, you use the longitude, latitude, and elevation. You don't need a projective coordinate system. But if you use a PCS, then you need a GCS as its foundation. Okay? So this is part I want to emphasize. Any question? You are so smart, you never have questions. That's perfect. Now I want to resume task 7, which is more interesting than yesterday's tasks. So I have 3 questions or 3 problems to solve. How do you calculate shortest path? How do you calculate cost matrices? And how do you calculate point densities? Let's go through them one by one. Shortest path means you want to go from one point to another, then to another, then to the last point. And how do you choose the path that is shortest according to a weight of each length? Let me show you how you do it in ArcMap. So this is very tricky actually. I have to zoom in. It's very tricky. And if you don't use this for a while, you are going to forget it. The first thing is, this thing is done by an extension of ArcMap called Network Analyst. In order to use Network Analyst, you have to right-click the toolbar and select Network Analyst. So this is the first step. Then you are going to see this bar, okay? And you will see everything gray. And you don't know how to use it. So somebody will tell you to go Tools and Extensions, make sure it's added. So if you see these extensions always gray, and no button can be clicked, make sure this extensions in Tools menu is selected. Okay. The reason for this is that S3 are selling their licenses separately. So if you want to use Network Analyst, you have to borrow a license. And if you click this, you are going to borrow a license. So don't forget to select Tools, Extensions, and check Network Analyst. And Network Analyst is based on a network. Now you are going to look for a network. For example, I found a network here. So here is a network, and I want to analyze. I still see all the options gray. I cannot choose them. The reason is that to analyze a network, you first have to create a network. The shapefile of a polyline looks like a network, but it's not a network format that ArcMap needs, because it doesn't have all the necessary topological information. So you have to build a network dataset, and you cannot do it from ArcMap, so you have to launch ArcCatalog. I think I definitely will forget this, in half a year. So here is the dataset. Another tricky thing is, ArcCatalog cannot create a network dataset from anything in the FileGL database. So you first have to right-click this layer and export to shapefile. So it's a warning. Okay. Then you want to output this dataset to somewhere. And a name. provide name. For example, I provided a name called net. Okay. Then I create a new shapefile here. You still have to make sure you check these extensions in Arc catalog. Otherwise, you won't see any options. So make sure you check these extensions again, and then right-click this net. In this way, you are going to see an option to create a new network dataset. And the network dataset is the data you want to analyze. You want to calculate shortest path. So it will ask you to enter the name, and you just next. Now here is the attribute of the the network dataset. So if you don't want to use the length to calculate shortest path, you can use another field you specify as the cost of each link. Okay? The next. Just next several times. And now the network set has been created and you want to build it. Okay, so now you see a new dataset, a new network dataset called NetND. You can preview it. It's the same shape, okay? And another dataset called junctions. So originally we have a shapefile named net. Now we have NetND and NetND junctions. And then we go back to ArcMap. We have to load the network dataset, NetND. Let me remove this. So now we see all the buttons, all the functions usable. The first thing we want to do is a new route, which is a new shortest path. By doing this, we will be able to mark some locations. This is first. So this is first location. For example, this is second location, third location. Then, if we click this button, solve, it's going to give you the shortest path. And you can check the information of the shortest path here. So, which edges, which links, and which junctions is involved. Another information, another important thing is directions window. By clicking this directions window, you can see how you go from go through these points. It's like the functionality in Google Map, right? So that's solve the problem of shortest path calculation. The next question is about cost matrix. So now you not only want to calculate shortest path from one place to another. You want to calculate the shortest path for many OD pairs. Let me just clear everything. Remove the roots. Remove. Okay, so now we go back to our network dataset. The next thing we want to do is calculate a new OD cost matrix. The new OD cost matrix means the cost matrix for a certain OD matrix. So for each OD pair, we are going to calculate how distant they are. So you click new OD cost matrix, and you load some origins. So here you see an OD cost matrix. OD cost matrix is from origins to destinations. Then you want to click this bar, okay? Show hide network analyst window. I probably will forget this very soon. Sure. So origins, right click and load locations. Then we load some locations. For example, we have building centroids. Okay, so these are the points I want to set as origins. Maybe they are too much and too many. Let me remove some of them. Too many. It's not good. See again. So right click and load locations. And choose another data set, sub area, pick location. So they're all here. So I have 63 origins, and now I want to load the destinations by using the same way, same method. So I can still load 63 points. Now I have 63 by 63 matrix. And where is my toolbar? Oh, it's here. In this way, I can click solve. And we are going to see a very complex thing. So let me do it again. Let me remove most of the destinations. Let me change the lines. Secret. So you see what it is. Here, each line is representing the cost or the shortest distance, the distance from one point to another. If you right-click these lines, and choose Open Attributes, you actually will see from each origin to each destination what's the total length of the shortest path. Okay, this is not a straight line length, it's length based on the network. Okay, so this is the OD cost matrix, and you can also see that from my slide. This thing. And sometimes you want to export this table as your OD cost matrix for some of your algorithms. The next one is also very exciting. It's about point density. So let me first tell you what point density is. Point density simply means the density of points at every location. And the way they are calculating the point density is by specifying